Having seen the three fundamental concepts behind the smart way of doing arithmetic calculations, let's get started with multiplication. We're going to be using the complementary method. What is this complementary method? Right? I introduced this when I was talking about the three fundamentals, right? So whenever we look at a number, right, we try to see the number from the perspective of a base number. Base numbers are 100, 1000, 10,000, and so on. So the number that you are seeing is 8 and 9. The base number is 10. And what is the complement with respect to the base number? In the case of 8, it is 2. In the case of 9, it is 1. If you see the numbers 91 and 94, you can compare it to the base number 100. So 91 is short of 9, to 100, right? So that's what we mean as complement of 100. So 94, it is 6. So let's see if you have got these numbers, right? We have also computed the complement. How do we go about finding the multiplication value of these numbers? That's what we are going to see, right? So that's what this method is all about. So let's start with the first example. 8 into 9, right? How will you do it? So let's write numbers 8 and 9. Complement of 10 is 2 and 1, right? So what are the next steps? So this is the first step, right? When you have two numbers, you have compared it against the base number, found their complement, and now you have put it in the form of a table like this, right? 8 and 9, 2 and 1. So the first step is to find the difference between 9 and 2. Or you can also do it between 8 and 1. Both the values will be same, right? In this case, it is 7. I have now computed the difference, right? What is the next step? I multiply. 2 into 1 is 2. So what is the answer? 72. So why are you going in for difference here between 9 and 2? That is because this numbers 8 and 9 are less than 10. If these numbers are more than 10, for example, if it is 12 and 11, right, I will actually add instead of finding the difference, right? In fact, we will see one more example where we will have numbers more than 10. Okay, we will see an example where one number is more than 10 and another number is less than 10. That example is also something we will see, right? This is very easy, right? I know 8 and 9 is fairly simple, right? So this method is really useful when you come to double digits, triple digits, 4 digits, so on and so forth, right? So whenever you look at a number, you see if that number can be represented as a complement of the base number. If that is a possibility, you can definitely use this technique to multiply, right? So let's see one more example. In the case of 8 into 8, I want to explain using a simple single digit itself, right? So what is the complement? 2 and 2, right? So you have represented this in the form of a table, right? So what is the next step? You're going to find the difference, right? 6, 8 and 2. You have 6. And now you're going to multiply 2 into 2, right? And what is the answer? 8 into 8 is 64. Here it should be 8 into 8, not 8 into 9. Okay, it should actually be 8 into 8. Okay, so 8 into 8 is 64, right? So let's see another example. What will be 6 into 7? 6 and 7 can be represented as complement of 10, 4 and 3, right? With respect to 10, difference between 10 and 6 is 4, difference between 10 and 7 is 3, right? I am less here, So I have to subtract or find the difference. 7 minus 4 is 3. You can also do 6 minus 3, right? Whichever way, right? You take any one of the two directions, right? So the difference is 3. What is the next step? You're going to multiply 4 into 3, right? Because I am multiplying a single digit into a single digit, my answer can only be a double digit, right? Unless it crosses a certain number, right? In the case of you're multiplying two single digits, so the answer has to be a double digit, right? So what do? You got 3 and 12. The answer cannot be 312. That will be a three-digit number, right? That is not possible. So what do? You split this number 1 and 2, right? Split it as 1 and 2. And what do you do with the 1? You go and add this, right? Like a carryover. So what is the answer? 3 and 1 is 4. You already have 2. The answer is 42, right? Because the multiplication of any two single digits, it can only result in a two-digit number, right? So for 4 and 3 I got 12. I splitted this number as 2 and 1 is carried over. Easy, right? So we have all been doing single digit multiplication, which you might possibly remember by heart also, right? As part of multiplication tables, right? As I said, this technique is very useful when it comes to double digits, right? But I want to start with the basics, start with the easy ones, so that you clearly understand, right? Now we will go to the double digit, okay, which is the next example. 94 into 96. Remember, to do 94 into 96, how long it normally takes for you, the conventional route. Okay. In fact, after you have learnt it, okay, I will even suggest that you take a stopwatch, right, to find out the number of seconds you take to compute this 94 into 96 after having learned this technique. Okay, I'm sure it'll be in a matter of seconds, and that is not possible using the traditional route. Okay, even for experienced people, okay, even for people with a good knowledge and good interest level in mathematics, it takes time, right? But we are going to see how to do it in a matter of seconds, right? You've already seen that. This is a double digit now, right? 94 into 96. You represent this as complement of 100, right? 0, 6 and 0, 4. Note, I am putting it as 0, 6 and 0, 4. Why? Because this is a two-digit number, right? In the earlier one, I wrote it as mere, in the case of 8 and 7, as 2 and 3, right? You see here, I am representing here as 2 and 1. When it comes to 100, it must be represented as 6 and 4 for this computation. While introducing the concept, I did not put here because I wanted you to understand. Now that you have understood how the complement way of multiplication works, okay, I want you to note that when you have two-digit numbers, when you are representing it as complement of 100, it must be represented as a two-digit, right? Because only then multiplication of two-digit numbers will result in a four-digit number, right? That is why you must represent this as 0, 6 and 0, 4, right? So what do you do first? Now that you have represented this, find the difference, right? 96 minus 6 is 90, or you can do 94 minus 4 also. You have 90, and then what? You multiply 24. And what is the answer? 90, 24, right? Matter of seconds, right? Okay. Really powerful. This is one technique that'll hit you like anything, right? You can truly understand the power of these techniques, right? What used to take minutes, you can do it in a matter of seconds. Okay, Now, let's see one more example, right? 81 into 96. How will you represent 81, 96? 19 and 04, right? What do you do? 96 minus 19 or 81 minus 4, right? Maybe 81 minus 4 is easier to do. Anyway, the answer will be the same, right? 77. Then you multiply 19 into 4, and what is the answer? That's it. 7776. That's the answer. Easy, right? Okay. One more example. Now we will see here 3-digit number, right? This will definitely take minutes, right? In the conventional way. You're now going to see how to represent this, right? Because it's a 3-digit, I put 007, right? 002. That's how I put, right? Because it's a 3-digit number. So what is the first step? I find the difference, right? 991. Then what do? You multiply 014. Remember, because we are representing this as complements of base 1000, right? Because it's a 3-digit number, I must represent this as 007, right? And the first step is I find the difference, either this or this, right? Any one. The result will be the same, right? As in the previous examples. 991, 7 into 2 is 14, right? 014. And what is the answer? That's it. How long it took for us, right? Easy, right? So go ahead and try, right? It's a very, very powerful technique, okay? And makes you do, large sums, large numbers, multiplication of large numbers in a matter of seconds. Okay, we have one more example, right? What if I have uh, plus 2 and plus 4 kind of scenario, right? That's more than 10, right? So previous examples where the numbers were less than the base numbers. Here the numbers are more than the base numbers. How will you do? The process is the same. Instead of finding the difference, I add. That's all I do, right? I have put it here as plus so that you understand, right? You don't need to put. As I said, the objective is we want you to do all of this mentally, right? When you start off, maybe you can use a paper, right? Pen and paper, or pencil and paper to do these computations. But over time, we want you to do these computations in your mind, right? So 12 can be represented as plus 2, right? 14 can be represented as plus 4, right? If it is more than the base number, you have to add. If it is less than the base number, you have to find the difference, right? So that's what we are going to do here, right? So we have represented 12 and 14 as plus 2 and plus 4. We are going to add. 14 plus 2 is 16, and then 2 into 4 is 8, right? See, we are not representing this as 02 and 04 because these are represented with respect to 10. Though they are double digits, they are not represented with respect to base 100. Here they are represented as complements of 10 only, right? So I put this as 2, not 02, right? And what is the answer? The answer is 168, right? So we will see one more example where we have a mix of a number more than the base and another number which is less than the base, right? So we have 12 into 8. So 12 will be represented as plus 2, 8 will be represented as minus 2, right? So what do? In this case, you add. If you're going to go for this route, you're going to subtract. Very simple, right? So you have added here 8 plus 2 is 10, or if you are going to take this route, 12 and minus 2, you want to subtract, right? 12 minus 2 is 10. Plus 2 into minus 2 is minus 4. This is where this gets interesting. Now, how can you represent 10 minus 4? How can you combine a positive number and a negative number? You can represent it as 104 and put a bar, right, to indicate this 4 is a negative number, right? Which means I have to actually subtract this 4 from 100, right? This is what? 100 plus minus 4, right? I am representing this minus 4 as 4 bar, right? I'm just putting it a bar, above this 4, indicating that this 4 must be subtracted, right? Remember, this is going to be a 2-digit number, right? So it becomes 100 minus 4, and I will have the answer as 96, right? So you understand how we can multiply when one number is more than the base, the other number is less than the base, right? You can use this concept of bar, right, and subtract appropriately to arrive at your answer. Clear? I hope this gives you an approach, right, a technique to compute 2-digit, 3-digit multiplications faster and in your minds, right? So this completes the complementary method of multiplication. In the next session, we are going to see how to multiply numbers using another technique called as vertical and crosswise. Okay.